Welcome back. In this video, we're going to take a look at Java's map data structure. I wanted us to start with a bunch of already formatted information. So I began this video by creating a little program on my own. I would encourage you to find this program in the companion files for the course and take a look through it. Make sure you understand how it works. I'm operating on the assumption that we're not yet familiar with file input and output, so I dropped all of the data that we'd normally want to store in a file or somewhere more manageable right into the code of our program. This data is an array that I've called all names, and what it is a list of names of famous people. And their individual first and last names are also divided up. So Jane Addams comprises the first two elements of the array, her first name at all names 0, and then Addams, her last name, at all names 1, and so on, with every two elements in the array being a single person's first and last names. This is also a good chance for me to show you a nifty little NetBeans feature that's available in most IDEs. We can talk to our IDEs often, if they support features like this, by putting instructions for them in the comments of our code. Because these instructions are commented out, they won't in any way affect the way our Java code compiles and runs. But we can talk to the IDE. This instruction here, paired with its ending instruction down here, tells NetBeans that we'd like it to section off this code so that we can use our little box over here to expand and contract the block of code. It doesn't make the code go away, it just hides it from us so that we can develop without it cluttering up our screen. Now, a very quick explanation of the program I've written to start this video off. We have an array of strings that contains the first and last names of a bunch of famous people. And the program I've written simply loops through this array and determines if it's looking at a first or a last name, and then places those names in separate arrays of their own. At the end, when we print out these arrays, we have two separate arrays, one of first names and one of last names. And the relationship of these arrays, because we've placed them into the two separate arrays in order, is that the indices of the arrays match up. So at first name 0 and last name 0, we have the first and last names of Jane Addams. What I'd like to do now is expand this program and place all of this information in a single data structure, a Java map. What maps do is basically take two sets of information. And while we create that map, we let it know a relationship between one set, which we'll call the keys, and the other set, which we'll call the values, such that each key maps to a value. This will allow us to ask our program questions like, given a famous person's last name, what is the first name that associates with it? To begin, I've gone ahead and imported java.util, where the map interface lives. Now, let's get rid of these print line statements, and instead, at this point in our code, when our first names and last names arrays have been set up, let's start constructing our map. Let's begin by using the map keyword. And then, as with most data structures, we need to tell Java what type of information our map is going to take. Maps take two sets of information, so we're actually going to have to give it two types, comma separated. The first information type is the information type for the map's keys. We're going to use last names as our keys because we don't want our map to store multiple values in one key. And it's much less likely that we're going to have multiple last names. Additionally, it's a lot more valuable for us to ask the first name of the famous person named Addams rather than the last name of the famous person named Jane, of which there are probably much more. Anyway, the data type of last names is string, and actually the data type of first names is string as well. Now we give our new map variable a name, and it's time to cause it to come into being, to instantiate it. To do this, we use the new keyword. And then map is not actually an object. It's what we call an interface. For the most part, we interact with interfaces and objects the same way. But we cannot simply declare an instance of an interface. Rather, interfaces are additional wrappings of functionality that we place on top of objects, much in the way that array lists add additional functionality to arrays. So, to create a new map, we need a simpler type of object which we can wrap the map interface around. A great candidate for this is the hash map. Once we've created our hash map and assigned our map variable to it, we now interact with this famous people variable just as if it was an object with all of the map functionality. Additionally, if we would like, we could call hash map only functionality on this object as well. While it's a little out of the scope of this particular video, the power of interfaces is that we can assign them to objects of different types, giving common functionalities to otherwise distinct object types. But for now, we're mostly just interested in the power and function of Java maps. You'll notice that we didn't have to explicitly tell Java what types our hash map was going to take. This is a stylistic choice, really. If we wanted to, we could explicitly declare the types that the hash map would take. But since we're only going to interact with our hash map in terms of its functionality as a map, simply protecting us from adding anything but strings when we interact with our hash map through this variable, which is currently our only way to access it, should be just fine. Once we've set up our map, it's time for us to go through and fill it with information. For this, I think a for loop will be appropriate. We're going to need to add a number of pairs of information, that is one key and one value, equal to the number of items in either of these arrays, because they have the same length. So let's just choose last names. And we'll set up a for loop that iterates through every index from I to the length of last names minus 1. These I values will map to the indexes of the last names array. And because the first names array has the same length as the last names array, the first names array as well. Now, for each I, we're going to execute our maps put function. The put function is similar to an add function. It inserts information into our map. However, this function expects two pieces of information. It expects first our key, which is the value we're currently looking at in last names, and then it expects the associated value. This is the value we're looking at in first names. Each time we execute this line of code, we'll be adding a new key value pair to our map. Once we've set up the map, because with all our information already in our program, that's all we need to do, it's time to ask it some questions. It would be perfectly possible for us to create some nice user input for this program, but I think at this point in time it would be a little tedious. So let's just ask our program some explicit questions right here and make sure we get the right responses. we use the get function to ask our map its basic question that it's designed to answer. What is the value paired with a given key? So let's ask our map, what is the value paired with Adams? Or, put in more human understandable English terms, what is the first name of the person in our map whose last name is Adams? When we run this program, we get the expected result, Jane. And let's just run it one more time to make sure we haven't made any silly mistakes. Let's see if our program answers Frank for Sinatra. And indeed it does. While it's possible for us to write a program like this simply by looping through our arrays when we get user input and finding a last name and then storing that index and getting it from first names, our map interface essentially does that for us. Perhaps more importantly than that, when we're working with other programmers or looking at code that we didn't write just yesterday and we see a map, we understand immediately its intended purpose and what functionality it implements. In almost all cases, just writing code that works is equally important, and maybe not even as important, as writing code that works because it makes sense and will be understood by others and yourself who come across the code in the future. As always,